So consider this problem statement. So here some statements are given like statement S1 and S2. So S1 says that there exists infinite set, that is ABC, such that A intersection B union C is finite. Statement 2 says that there exists two irrational numbers x and y such that x plus y is rational. So which of the following statement is true about S1 and S2, right? And these are the options given. So give it a pause and try. Okay. So now let us try to solve this one. Now here S1 says that there exists infinite sets A intersection B, sorry, A and A B C such that A intersection B union C is finite. Now, so for this I'll take some assumption. Okay. So assume that I'll consider my universal set as the set of natural numbers, right? 1, 2, 3, and so on. So this is my set U. And now let us consider for set A, I will consider the set of even numbers 2, 4, 6, 8, and so on. These are, since these are infinite, so we do not know the last element. For set B, I'll consider them as set of, let's say, primes 2, 3, 5, 7, and it goes on continuously. And for set C, you can make a smart guess over here that I will be taking the set of odd numbers 1, 3, 5, 7, and so on. Right. So these are this is my starting assumption. Now I'll perform this computation, whatever is demanded here. So this is whether this is finite or infinite. Let us make a check. Right. So here we have A intersection B union C. So this one we can write it as, first of all, let us perform B union C. So I will write my set A as it is, right? And then intersection B union C. And here I'll perform B union C. So this is my set B. So instead of this, I'll be writing this set B over here. And this is my set of odd numbers. So I will take set of odd numbers over here. And I'll give a parenthesis here. Yes. Now let us perform this union operation first of all. So when we perform this union operation, the internal one, right? So this gives out 1, 2, 3, 5, 7, 9, and then 11, 13, and so on. Correct. So this is the union operation. Now, if you observe, we have taken the number sets in such a way so that it's very clear that from the property of primes that there exist, I have used exactly this property, that there exists only one even prime, even number which is prime. So from this, if I take the intersection, I'll get 2 here. So you can clearly observe that set of even numbers is infinite, set of prime number is infinite, and set of odd number is again infinite. And when I perform this operation, then it is finite, right? So you can observe this statement is true. So we can clearly say that S1 is true. So we can conclude that that statement S1 is indeed true, right? Now let us talk about the next statement, that is statement S2, that there exist two irrational numbers x and y such that x and y is rational. Okay. So now for this statement 2, what I'm going to do is that I can take, let us say, for x, let me consider a real number. For x, let me consider a real number, that is 1 plus square root of 3. And for y, let me consider 1 minus square root of 3. Now on adding this, if I add x plus y, so you can clearly observe that 1 plus square root of 3 minus, here 1 minus square root of 3, 1 minus square root of 3. So you can observe the irrational part will be eliminated and we will be having a rational number. So here, okay, where 2 is rational number, right? So from this we can clearly say, from this we can observe that there exists two irrational number. Yes, we have taken two irrational number such that x plus y is rational. So from this we can say, that statement S2 is also true. And now let us check the options one by one. So only S1 is correct. No, that is not the fact here. Only S2. No, they are both correct actually. So both S1 and S2 is correct, right? So from this we can say, that answer C is the correct option for this particular problem statement. So I hope it is clear to everyone.